This one discovery changed everything we thought we knew about the biggest beast that ever lived. Forget T-Rex, forget the blue whale. 30 million years ago, a creature the size of 4 elephants stood in a Pakistan forest, reached up with its giraffe-like neck, and stripped leaves from treetops with a trunk-like nose. Meet Paraceratherium, the hornless rhino that became the largest land mammal to ever walk our planet. And it vanished without leaving a single descendant behind. 30 million years ago, during the Oligocene epoch, the world was cooling and changing rapidly. The rocky deserts of modern Pakistan were lush, tropical forests stretching to every horizon. This was when the prehistoric Rhino dynasty reached its peak, producing creatures so massive they made modern elephants look like ponies. But these giants faced a brutal reality: grow huge or die. And for a few million years, growing huge actually worked. Before we continue, subscribe to my channel for more mind-blowing facts on the wonders of the ancient world. The story of Paraceratherium begins with a case of mistaken identity that lasted decades. When paleontologists first discovered fragments of these massive bones in the early 1900s, they had no idea what they were dealing with. The bones were so enormous that scientists initially thought they came from some unknown species of elephant or even a dinosaur that had somehow survived extinction. It wasn't until more complete fossils were uncovered that the shocking truth emerged. This was a rhinoceros, but unlike any rhino that had ever existed. Picture the most alien-looking creature your mind can conjure. Paraceratherium had the body of a rhinoceros scaled up to impossible proportions, but with a neck that stretched skyward like a giraffe's, and a long, flexible upper lip that worked like a tapir's trunk. Most shocking of all, it had no horn whatsoever. The name Paraceratherium literally means near the hornless beast. And that's exactly what it was: the ultimate evolutionary experiment in rhinoceros design. The scale of these creatures defies comprehension. A single skull measured over 4 feet long, bigger than most people are tall. Individual neck vertebrae were the size of car steering wheels. The complete animal stretched over 26 feet from nose to tail and stood 18 feet tall at the shoulder. To put that in perspective, you could walk underneath one without ducking. The largest specimens of Zungariotherium orgosense, a closely related species, weighed over 20 tons. That's heavier than 3 full-grown African elephants combined. Their legs were like living pillars, designed purely for supporting unimaginable weight. These weren't built for running or even walking quickly. The bone structure shows they could only manage a fast walk at best, but when you weigh 20 tons and have no natural predators, speed becomes irrelevant. Adult Paraceratherium had essentially removed themselves from the food chain through sheer size alone. The feeding strategy of these giants was as specialized as their anatomy. Those simple, low-crowned teeth were perfectly designed for one thing: stripping soft leaves and shoots from the highest branches. The long, flexible upper lip could wrap around branches like a prehensile trunk, while the elongated neck allowed them to browse at heights no other land animal could reach. They were living hedge trimmers, sculpting the forest canopy as they fed. What made Paraceratherium truly remarkable wasn't just its size but its place in rhino evolution. This creature belonged to a group called Hyracodonts, ironically nicknamed running rhinos. The irony is brutal. While their smaller relatives were indeed built for speed, Paraceratherium had evolved in the opposite direction. Some Hyracodonts were dog-sized sprinters that could outrun most predators. Others became the largest land mammals in Earth's history. Evolution rarely creates such extremes within a single family group. The world these giants inhabited was nothing like the Pakistan we know today. 30 million years ago, this region was covered in dense, humid forests with rivers meandering through countless groves of trees. The climate was warm and stable, perfect for supporting massive herbivores that needed enormous amounts of vegetation to survive. Fossil evidence shows they shared this paradise with early elephants, primitive horses, and giant crocodiles that posed a threat only to juveniles. The discovery locations of Paraceratherium fossils tell an incredible story of continental movement. Remains have been found from Eastern Europe all the way to Mongolia, proving these creatures once roamed across vast stretches of Asia. This distribution helped scientists understand continental drift, showing how land masses that are now separated by thousands of miles were once connected. The Rhino dynasty was so successful that they conquered an entire continent. But success in the prehistoric world was always temporary. The very traits that made Paraceratherium dominant also made them vulnerable. Their massive size required enormous amounts of food, stable climate conditions, and firm ground to support their weight. They had tiny brains relative to their body size, suggesting limited behavioral flexibility. Most critically, they reproduce slowly, probably having long pregnancies and raising single calves like modern elephants do. The cooling climate of the Oligocene began changing the very foundations of Paraceratherium's world. As temperatures dropped, the lush forests started giving way to grasslands. The soft-leaved trees these giants depended on became scarce, replaced by tough grasses their simple teeth couldn't process. Meanwhile, their competitors were adapting. Early elephants developed more flexible feeding strategies and better social behaviors, allowing them to exploit the changing environment more effectively. The extinction of Paraceratherium represents one of evolution's most dramatic dead ends. Unlike other prehistoric giants that left modern descendants, the entire Hyracoodont line vanished completely. Their closest living relative is the tiny, critically endangered Sumatran rhinoceros, weighing less than 2,000 pounds compared to Paraceratherium's 40,000 pounds. It's like comparing a house cat to a tiger, except the size difference is even more extreme. What makes their disappearance even more mysterious is how complete it was. Despite ruling Asia for millions of years, they left almost no fossil evidence. Complete skeletons have never been found, only fragmentary remains that paleontologists piece together like a massive jigsaw puzzle with most pieces missing. This scarcity suggests they lived in environments where fossilization was rare, probably avoiding wetlands and riverbanks where bones typically get preserved. The few fossils we have reveal incredible anatomical details. The nasal openings were set far back on the skull, indicating they had large soft-tissue noses, possibly even more pronounced than a tapir's. The distinctive gap between front and back teeth shows they had specialized feeding behaviors. Some scientists think the large nasal cavities could have been used for infrasonic communication, allowing these giants to call to each other across vast distances using sounds below human hearing. Their molars had a unique pie-shaped pattern on the grinding surface, perfectly adapted for processing the specific types of vegetation available in Oligocene forests. This specialization was both their strength and their weakness. When the climate changed and their preferred food sources disappeared, they couldn't adapt quickly enough to survive. The social behavior of Paraceratherium remains largely mysterious. Most evidence suggests they were solitary animals like modern rhinos, coming together only to mate. Their large ears, indicated by skull structure, probably helped with heat dissipation in the warm climate. The slow reproductive rate meant populations couldn't recover quickly from environmental stresses or competition pressure. Young Paraceratherium faced dangers that adults could ignore. Giant crocodiles lurking in rivers could snatch juveniles, and terrestrial predators called creodonts hunted anything they could overpower. Only by reaching adult size could these rhinos achieve true safety, but that journey from vulnerable calf to invulnerable giant was fraught with peril. The geological context of Paraceratherium fossils reveals they preferred areas with firm, stable ground. Their massive weight meant they couldn't venture into swampy areas or unstable terrain. This habitat restriction became increasingly problematic as climate change altered landscapes across their range. Areas that had supported them for millions of years became unsuitable within relatively short geological timeframes. Modern paleontologists continue debating the exact number of Paraceratherium species. Some argue for multiple distinct species spread across different regions and time periods. Others suggest we're looking at regional variations of a single, highly successful species that dominated an entire continent. The fragmentary nature of the fossil record makes definitive answers difficult. The legacy of these prehistoric giants extends beyond paleontology. Paraceratherium has become the state fossil of Balochistan, Pakistan, honoring the region where some of the best specimens were discovered. They've appeared in documentaries like BBC's Walking with Beasts, bringing these incredible creatures back to life for modern audiences. Yet their name remains frequently misspelled in popular media, a small indignity for such magnificent beasts. The evolutionary lesson of Paraceratherium is both inspiring and sobering. For millions of years, these creatures proved that size could be a successful survival strategy. They grew so large that predators couldn't threaten them, competitors couldn't challenge them, and they dominated their environment completely. But that same extreme specialization made them vulnerable to environmental change. When grasslands began replacing forests, when climate patterns shifted, when more adaptable competitors arrived, the prehistoric Rhino dynasty collapsed completely. No gradual decline, no evolutionary transition to smaller forms, just complete extinction. They represent one of evolution's most dramatic experiments in gigantism and one of its most complete failures. The disappearance of Paraceratherium left a massive ecological void that took millions of years to fill. No other land mammal has ever approached their estimated body mass. Modern elephants, despite being the largest land animals alive today, are dwarfed by these ancient giants. The niche they occupied simply ceased to exist when the world changed around them. So the next time you see a modern rhinoceros and marvel at its impressive size, remember the forgotten dynasty that came before. 30 million years ago, hornless giants the size of buildings roamed Asian forests, reaching heights no land animal had achieved before or since. They ruled their world so completely that they forgot the first rule of survival: adapt or perish. When the world changed, the largest land mammals in Earth's history vanished without a trace, leaving only fragments of bone to remind us they ever existed. If that makes you appreciate how remarkable survival really is, hit that like button, subscribe for more incredible stories from our planet's deep past, and share this with someone who thinks modern elephants are huge, because compared to the prehistoric Rhino dynasty, today's giants are just gentle shadows of the true titans that once shook the earth with every step.